Hello, and welcome to Science with Mr. Morgan. In today's episode, we're going to talk about forces. Now, when I say force, am I talking about the energy utilized by Jedi and Sith alike? Maybe in some cases if we're having a conversation about the Star Wars franchise, but right now I am talking about a push or a pull that is acting on an object. Now, there are multiple fundamental forces in the universe, which include the force of gravity, electromagnetic forces, and weak and strong nuclear forces. The motion of everyday objects occurs because of a combination of different kinds of forces, and these mainly include gravity, friction, and applied forces. So what is an applied force? An applied force is just a force that a person or thing applies to an object, like pushing a door open. Now, like we touched on in the objects in motion lesson, force causes all motions. Every time the motion of an object changes, it's because a force has been applied to it. And forces can cause the following: stationary objects to start moving, a moving object to change its speed, direction, or both, or even a moving object coming to a complete stop, which would fall under changing its speed. Now remember, acceleration, which is dependent on the strength of the force and the object's mass. This is why heavier items are harder to accelerate. The SI unit for force is the Newton. And just like we talked about in another episode, forces are vectors because they have both size and direction, right? Vectors have size and direction. Now, what happens when we combine forces? Well, an object will move in the direction of the stronger force. And this brings up the concept of net force. Net force is a combination of all of the individual forces acting on an object. When forces act in opposite directions, the net force is the difference between forces. This is always greater than or equal to 0, but less than either of the individual forces. When forces act in the same direction, the net force is the sum of all forces. And this is always greater than either of the individual forces. So, here I've got these two pictures. First up, we're going to look at the soccer one. What is the net force of the soccer ball pictured on the screen? Well, the player in yellow applies 75 newtons of force to the soccer ball from the left towards the right. The orange player applies 125 newtons of force to the soccer ball from the right towards the left. And since these forces are being applied in opposite directions, you find the difference between the two. 125 newtons minus 75 newtons results in 50 newtons, and it's being applied to the left. This other picture, what is the net force of the box? Well, the character pushing is applying 50 newtons of force to the right, and the character pulling is applying 75 newtons of force also to the right. Since these forces are being applied in the same direction, you find the sum of them. 50 newtons plus 75 newtons results in 125 newtons being applied to the right. Now let's take some time now to look at different types of forces. The ones that we're going to cover are elastic force, friction, of which there are various types that we're going to cover, and gravity. First up is elastic force. With elastic force, items have elasticity. Elasticity is the ability of something to return to its original shape after being stretched or compressed. Now, elastic force is the force exerted when an elastic material is stretched or compressed. It increases the more that the material is stretched or the more that the material is compressed. And real-life examples of things with elastic force include stuff like hair ties, rubber bands, slinkies, springs. Enough about elasticity and elastic force, though. Now we're going to talk about friction. And friction is a force that opposes motion between any surfaces that are touching. For example, your hands. Now, friction can work for us, or it can work against us. Sand on an icy sidewalk is an example of how friction can work for us. The sand provides grit and it helps to stop people from slipping. Wearing out engine parts is an example of how friction can work against us. Over time, the engine parts break down and need to be replaced, which is why it's very important to have oil in your engine because it helps lubricate the parts and reduces the amount of friction, which means it reduces the amount of wear and tear, therefore lengthening the life of your engine. It doesn't get rid of friction entirely, but it does lower the amount. Now, no surface is perfectly smooth, which is what allows friction to occur. Even surfaces that appear smooth, like your phone screen, for example, or the screen of this computer, they appear smooth, but they are actually bumpy, which you can see under a microscope. Rougher surfaces have more friction than smoother ones do, which is visible to you most of the time because you can see the surface is rougher, or feel it if you can't see it. For example, sandpaper versus ice. Sandpaper has a rougher surface. It produces more friction than ice does. The rougher the surface, the more friction there is. Heavier objects also have more friction because they press together with greater force. And a byproduct that results from friction is heat. This is because friction causes the molecules of rubbing surfaces to move faster, which leads to more energy, which results in a higher temperature, making things warmer. That's why when you rub your hands together a lot, it gets warm. Now, on to the different types of friction. There are 4 of them, and they are static, sliding, rolling, and fluid. Static, sliding, and rolling friction occur between solid surfaces, whereas fluid friction occurs in liquids and gases. Static friction is one that acts on objects when they are resting on a surface. Walking provides an example of this when walking on sand versus ice. Sand provides more static friction than ice does, so you're less likely to slip. Sliding friction, however, acts on objects when they are sliding over a surface, kind of like a penguin sliding on its stomach on ice. And this is weaker than static friction. This is also the reason that it is easier to slide a piece of furniture after you start sliding it. You've overcome the static friction and now you have sliding friction. The reason that pencils work the way they do is due to sliding friction. The pencil lead slides along the paper that you are writing on and leaves a mark from the friction. Rolling friction acts on objects when they are rolling over a surface. And this is much weaker than sliding friction or static friction. Wheels and ball bearings have rolling frictions. The last type of friction is fluid friction, which acts on objects moving through a fluid. What is a fluid? Well, it's a substance that can flow and take the shape of its container, which includes both liquids and gases. If you've ever been in a swimming pool and pushed your hand through the water, the feeling of resistance against your hand is fluid friction. Now, moving on from friction, let's take a look at gravity. Gravity is a force of attraction between things that have mass. Anything that has mass, no matter how small, exerts gravity on other matter. This means that you are exerting gravity on the pencil or pen in your hand writing notes, and at the same time that pencil or pen is exerting its gravity back on you. Now, gravity can also act between objects that aren't touching, even over long distances. Think about how the sun's gravity keeps us in orbit around the sun itself, even though we're 92 million miles away from the sun. The farther objects are apart from one another, the weaker the force of gravity is between them. However, this can be offset depending on the mass of the objects. The greater the mass, the greater the amount of gravity. And like I mentioned before, all objects have mass exert gravity on other objects. This includes the Earth, right? Earth's gravity is constantly pulling you towards the center of the planet. It pulls objects in the sky down, like meteors and skydivers, towards the ground. And at the same time, it also keeps satellites, both artificial man-made satellites as well as the moon, which is a natural satellite, circling around Earth. They're far enough away that they're not going to plummet down, but gravity is strong enough that it just keeps it looping around us. Now, talking about gravity involves talking about weight. Again, weight measures the force of gravity pulling downward on an object. And just like general force, the SI unit for weight is the Newton. On Earth, 1 kilogram is equal to approximately 10 newtons. On the moon, the same mass would weigh less because there is less gravity. Weight is measured with a scale that measures the force with which gravity pulls an object downward. Now, in another episode, we talked about Newton's laws of motion, but now we're going to talk about Newton again, this time Newton's law of gravity. Now, you may have heard the story of Isaac Newton and the apple tree. Long story short, it was claimed that Newton was sitting under an apple tree one day, an apple fell on his head, and he said, "Oh, gravity!" Now, the story itself is not true, but it's a good way to remember it. So Newton has a law known as Newton's law of universal gravitation, which states that the force of gravity affects everything with mass in the universe. The force that causes an apple to fall from a tree on the ground is the same force that causes the moon to keep moving around the Earth to keep moving around the sun, so on and so forth. The strength of gravity between any two objects depends on the two factors we've discussed at length now, mass and distance. Remember, the greater the mass, the stronger the force of gravity. The closer together objects are, the stronger the force of gravity. Now, aside from Newton, we also have Albert Einstein, who has a theory about gravity. Newton's law of gravity can predict the motion of most objects, however, not all of them. And his law doesn't really explain gravity, but it does describe the effects that gravity has on the motion of objects. Now, in the 1900s, Einstein came up with a theory of gravity that explains the missing pieces to Newton's law of gravitation. Einstein's theory claims that gravity is not really a force of attraction between all objects with mass, but a result of the warping of space-time instead. And Einstein's theory is supported by evidence and is widely accepted today. Now remember, it is just a theory, but so far everything is pointing in that direction. Now, moving away from laws and theories, let's look at acceleration due to gravity, as well as projectile and orbital motions. So, when objects fall to the ground, gravity causes them to accelerate. The longer the object falls, the faster the velocity gets. And this velocity increases by 9.8 meters per second squared. After 1 second of falling, the velocity would be 9.8 meters per second. After 2 seconds of falling, the velocity is 19.6 meters per second. And gravity causes this acceleration at a rate of 9.8 meters per second squared. And I say it again because it's a constant. It is important to note that all objects accelerate at the same rate regardless of mass, on Earth anyway. It's also important to note that this number can vary somewhat due to air resistance. If you didn't have air resistance, the numbers would change, but because we do have air resistance, it does cause things to slow down. On to projectile motion. So projectile motion is the movement of an object in a curved path towards the ground. This curved path is due to both a horizontal force and the downward force of gravity acting on it at the same time. Cannonballs and arrows are good examples of this in their arched pathway. So if you've ever shot a bow and arrow, you can shoot it straight out, but that arrow is going to have the horizontal force that you sent it with forward, but at the same time gravity is pulling down. So rather than a straight line from point A to point B, it follows a curved pathway. And then finally we have orbital motion. So orbital motion occurs whenever an object is moving forward and at the same time is being pulled by gravity towards another object. The forward velocity of the object combines with the acceleration due to gravity towards another object. And the result of this is a circular or ovular path, aka an orbit. One object keeps moving around the other. The strong gravity of the sun keeps the Earth orbiting the sun. The moon orbits the Earth rather than the sun because of the proximity, right? The moon is a lot closer to us, so the proximity to the Earth is superseding the strength of the sun's gravity just because the Earth is up close and it is here. And that brings us to the end of today's lesson. Until next time.